In this video, the focus is on remainder theorem, something very similar to factor theorem. What exactly was factor theorem? The factor theorem stated that if fx is a polynomial and this polynomial is being divided by a linear expression x minus a, and if f of a equals to 0, in other words x minus a is a linear factor. That was factor theorem. What if f of a does not equal to 0? F of a equals to a value r. This r is actually the remainder. Then the conclusion is x minus a, the linear expression, is not a factor because it leaves a remainder. This is the basics of remainder theorem. We can take the same example as we did in the factor theorem. That was about 6 being divided by 2. 2 3s are 6. The remainder is 1. In other words, 2 is a factor of 6. 7 being divided by 2. 2 3s are 6. The remainder is 1. Since remainder does not equal to 0, since remainder is actually 1, therefore 2 is not a factor of 7. Now let's do a question related with polynomials. Something like 2x cubed minus 5x squared negative 16x plus 10, and we want to divide it with x minus 4, a linear expression. Take the highest powered term in the numerator, highest powered term in the denominator, and that leaves us a quotient of 2x squared. So now, after multiplication, this is 2x cubed minus 8x squared. Change the sign and add. We are left with 3x squared. Take one more term down. Repeat the same process. 3x squared over x is 3x. After multiplication, 3x squared minus 12x. Change the sign and add. That leaves us with negative 4x. Pull one more term down, that is 10. Repeat the same process. Negative 4x over x is negative 4. So this is negative 4x plus 16. Change the sign and add. And what are we left with? We are left with negative 6. Now, we know that x minus 4 is not a linear factor of this cubic polynomial. Can we prove the same thing using remainder theorem? The answer is yes. So now let me rewrite this polynomial. Fx equals to 2x cubed minus 5x squared minus 16x plus 10. And I want to check whether x minus 4, a linear expression, is a factor or not. So what is the plug-in value? Take this linear bracket, equate it to 0. Therefore, the plug-in value is x equals to 4. Now let's plug in 4 in fx. So f of 4 is 2 into 4 cube, 5 into 4 square, negative 16 into 4 plus 10. That is 2 into 64, 5 into 16, 16 into 4 plus 10. So that is 128, negative 80, negative 64 plus 10. 128 and 10 adds up to 138. 80 and 64 with a negative sign adds up to 144. What is the difference? Negative 6. Now this negative 6 is the same number which was obtained after long division. So long division will give you the same answer. Just plugging in the value of 4 in fx was giving you the same answer. This is the concept of remainder theorem. Now this concept can be applied in solving questions in either one unknown or two unknown. Let's start with the first question. A polynomial is given as 8x power 4 minus 4x cubed plus ax squared minus 1. And it's given that when this expression is divided with 2x plus 1, it leaves a remainder of 3. So what is the question? Find the value of a. So now the solution is plug in value f of negative half. How did we achieve this value? 2x plus 1 equals to 0, x is negative half. So f of negative half should equal to 3 because the remainder is 3. It's not a factor, so it won't be equaling to 0. 8 into negative half raised to power of 4 minus 4 into negative half cube, a into negative half square minus 1 equals to 3. So therefore this is 8 multiplied with 1 over 16 positive minus 4 multiplied with negative 1 over 8, and a is being multiplied with 1/4, and this minus 1 I'm taking on the other side, that is 3 plus 1, which is 4. So this is half. This is also positive half, plus a multiplied with 1/4 equals to 4. Half plus half equals to 1. So therefore a into 1/4 comes out to be 4 minus 1, which is 3. Therefore a comes out to be 12. So without using a calculator, we solve for the value of a using the concept of remainder theorem. One more question which will involve the use of simultaneous equations. So now in this question, we have a polynomial fx equals to 3x cubed plus 2x squared minus px plus q. The examiner has given us two pieces of information. This expression, this function is completely divisible by x minus 1. Second piece of info, fx leaves a remainder of 10 when divided by x plus 1. And then as usual, what are they asking for? They are asking for find the value of p and the value of q. So first of all, when it says fx is completely divisible, what does it mean? It means that x minus 1 is a factor of fx. That means f of 1 should equal to 0 because the application of factor theorem is there clearly stated. Similarly, what is the second piece of info? The second piece of info is fx leaves a remainder of 10 when divided by x plus 1. So therefore f of minus 1 does not equal to 0. It equates to 10. Why? Because it leaves a remainder, and this is the application of remainder theorem. And you will form two equations and you will solve simultaneously to find the value of p and the value of q. So let's do this question completely. Fx is equal to 3x cubed plus 2x squared negative px plus q. First piece of info, it's completely divisible by x minus 1. In other words, x minus 1 is a factor. So therefore f of 1 should equal to 0. 3 into 1 cube, 2 into 1 square, negative p into 1 plus q equals to 0, 3 plus 2 negative p plus q equals to 0, negative p plus q equals to negative 5. Or we can write p minus q equals to positive 5. Let's form the second equation. The function fx leaves a remainder of 10 when it's being divided by x plus 1. So therefore f of minus 1 equals to 10. 3 into minus 1 cube plus 2 into minus 1 squared minus p into minus 1 plus q equals to 10. So therefore negative 3 plus 2 plus p plus q equals to 10. P plus q equals to, what are you left with? Negative 1 over here taken to the other side, that makes it 11. So I'll use this equation 1, I'll use this equation 2, I'll solve it simultaneously. So therefore negative p plus q equals to negative 5 and p plus q equals to 11. Simply add them up. So therefore 2q equals to 11 minus 5, which is 6. So therefore q comes out to be 3. Plug in any equation. I'll prefer the second one. So p plus q, which is 3, equals to 11. Therefore p comes out to be 8. So these were few examples that made us apply the concept of remainder theorem in questions related to polynomials.